Welcome to Superhero Conversations, a podcast saga with innovation leaders who are at SuperNova, the #1 tech innovation event in Benelux. I'm your host, Dominic G. Chuk, and joining me today is one of the superheroes of the local ecosystem, is a Redwire Space engineer, Stijn Ilsen. Welcome, Stijn.
Welcome, thanks a lot.
Stijn, I think this will be a fascinating conversation. So first, could you tell me, what do you actually do? How did you end up being a satellite engineer?
Well, I get the question a lot because usually people think if you're in space, you already dreamt of becoming an astronaut when you were 5 or 6 years old. I was not dreaming of becoming an astronaut. I was not really good at school. I had dyslexia, so I couldn't read very well. I'm colorblind, so I can never be a pilot or an astronaut. So space never really bothered me too much or never inspired me too much. But then at the age of 16, I went in a school trip to a space museum in the south of Belgium. It's a quite old museum, but when I was there, I'm not the most social person, but for some reason, I asked the guide there whether they're not looking for people who can work there as a guide in the summer. Because it's in the south of Belgium, they all speak French, so they must be looking for Dutch-speaking guides because there are a lot of Dutch people going there. And they said yes. So I did that for 7 summers. I gave tours, I trained kids. It was like an astronaut stage. So they came there for a whole week. It was the best. And I mean, explaining about space, it just bit me, and I was like, I need to do this. So I then said, okay, I'm still in the how do you call the middelbare school in English? I'm still in the
Middle school.
Middle school,
Yes.
voilà, middle school. So I was like 17, 18.
Uh-huh.
And I thought, where can I study space? And I found a university in Delft, the Netherlands. But my mother was like, yeah, but going abroad, and it costs a lot of money, and your grades are good, but are they that good? So she said, you first study industrial engineering in Antwerp for 1 year. If it's fine, and you're achieving your goals, fine, you can go to Holland. So I did, and I went to Holland. And then 5 years later, I came back in Belgium. I had my degree, aerospace engineer.
Wow.
And I thought, the world is at my feet. I can go anywhere now. So I applied for a space engineering job in Belgium. And there's actually one which is just 3 kilometers from my home. And I applied there and I said, I'm the guy you're looking for. Look, I have a space degree and you're a space company. You're looking for people. I know. No jobs. In Belgium at that time, there were no space jobs. Of course, there's always a wave. And yeah, they were going down. It was not the best time. So I got offers to be a dredging engineer, to be a consultant. But I knew that if I would take a job which is not space, then I would never come back to space. It's what happens. I mean, you get good at something, you get a better salary because you have some experience, and then you don't get back into space. So I did everything. I drove cars from boats. I worked at Decathlon. I worked everywhere until I got a job in space.
Mm-hmm.
And then I got a job in space. I worked in Germany, in the Netherlands, in Belgium. And after we got a couple of kids, we went back to our roots. We came back to Belgium, and now I'm a space engineer just 10 kilometers from here.
Wow. And could you explain us, what do space engineers actually do? What does it take? Because we hear it as a fancy kind of way of engineering that builds the rockets that you are sending it to Mars and so on. But what does
How is reality?
Yes, how is the reality? What do you do every day?
Yeah, reality is a bit different in the sense that there is no one type of space engineer. You have space engineers which are specialized in propulsion, in rocketry. Mm-hmm. You have space engineers which are specialized in satellites or in humans or in life support. So you have all kinds of space engineers. My specific job, if I have to explain to people, I always try to explain that I am a behavioral therapist for satellites. Meaning, when we are conceiving a new project, then I need to think about what should be the behavior of the satellite to meet the goal of the customer or the scientists. So I need to define what is the good behavior. Then we get hardware in, we start testing, and then I see that the satellite is probably not doing exactly what it's supposed to do. So I need to correct it a bit. I need to correct software, correct my thinking, correct the concepts. And eventually we are done. Everything is finally finalized. We launch. And then after launch, my job is mainly to make sure that it behaves and keeps on behaving as it should, and trying to tune and to calibrate and to move stuff away. So it's mainly working with software, with people to understand what they want, to translate it into software and into hardware which we need, and then launch it and enjoy the actual in-orbit operations.
Wow. And you have worked on multiple kind of satellite projects. Could you bring a one that really excites you the most and what you find that is your proudest kind of achievement?
It's difficult because I think the first project which you do is it's like your first love. You always have a special connection with that. I mean, it's just the way it is. It's the first time that you saw an actual satellite, the first time you saw a rocket, whatever the satellite was doing. I mean, it was fine. But the first satellite I worked on was a 1.1 billion euro space telescope. It's one of the biggest space telescopes we ever built. I was the payload engineer, meaning I was responsible for the 3 cameras which were on that satellite. I launched it from Kourou on an Ariane 5. We saw the actual launch. We were in the control room, and we could run out of the control room about 8 seconds prior to launch. So as soon as we could get out, we ran out and we saw it lifting up. So that's, I think, emotionally probably the most significant thing I can think of. That being said, 2 days ago, we achieved the goal of our latest satellites. We launched it in December. It's called Proba 3. It has actually 2 satellites, and one is actually round, and it flies in front of the sun, and therefore it casts a shadow. The shadow is actually picked up by another satellite, which has to position itself exactly 150 meters away with millimeter accuracy. This has never been done in space, because if you can do this, you can build space telescopes which are enormous. You're not limited to one small rocket anymore, like the James Webb, which has to deploy 25,000 steps to build a 10-meter telescope. No, we can build a 150-meter long telescope with 2 small satellites.
Wow.
And we launched it in December, and yesterday and the day before, we actually achieved that goal. We were at 150 meters. We were in the shadow. We opened our door, which is a door protecting the payload, and then we took images of the sun blocked by this fake moon. And I mean, I think that will scientifically change the most, because we will observe the sun in an unprecedented accuracy, which we can never do in any other way than what we have done.
Wow.
So it would probably change solar science a lot. I really hope so.
So this is the breaking news. First time
Yes,
you hear about it.
I had my keynote. I cannot show the picture of the sun because it's in the hands of the scientists. They want to play with it unit, but I showed some pictures where you could see the 2 satellites. Actually, the pictures are from one satellite towards the other, and you could see the other satellite slowly approaching and then entering the shadow, and then the shadow being fixed on the camera. It was amazing.
That's fantastic. I'm glad that we're having this conversation now.
Yeah, me too.
And could you explain what a satellite is? Because for a person like me, I love space. I like looking at stars, and I know that there are, I don't know, thousands of satellites circling around the orbit. But what is the intrinsic mission of a satellite? Why do we send those little thingies up to space?
The definition of a satellite is an object orbiting around a planet. So purely by definition, our moon is a satellite.
Okay.
That's why they call, in Dutch, they call a satellite a kunstmoon, a sort of artificial moon. It's nothing more than that. So it's a piece of metal with electronics which you orbit around a planet. You have different types. You have navigation satellites, which we use for GPS and Galileo. We have satellites looking down at the Earth, for climate, for espionage, for weather predictions, for a lot of different things, for talking to people around across the other side of the world. So there's a lot of things you can use satellites for.
Wow. And the one that you have sent in December and then achieved that new type of technology, what is the value that this particular satellite brings?
The value is that the story might be a bit long, but I'll try to summarize it in a couple of words. So the sun is a very active star. I mean, it has eruptions. Sometimes there are solar storms, and they propel charged particles, so electrons and neutrons, towards the Earth. We have a magnetosphere, which is like a shield around the Earth, and it protects us. Very nice. There are 2 holes in the shield, which is North Pole and South Pole. And then you see, when these particles enter the North and South Pole, you see the aurora.
Yes.
Aurora borealis. Magnificent.
Yeah.
With normal storms, this magnetosphere is sufficient. It's good enough. But when there are massive storms, it only happens every so many 100 years. But when there are massive storms, our magnetosphere will not protect us, meaning the auroras will get to our areas, even lower, to Spain, to even lower. And apart from looking at a very nice aurora, the bad thing is that these charged particles, they will play with our electronics. So the last time this happened was in 1859, something like that, long time ago. And at that point in time, there's not a lot of electronics on the Earth yet. It's more than 150 years ago. But the telegraphy network was already there. People could talk like on a primitive phone.
Yeah.
And all those phones were dead. The electronics just stopped. Either they stopped temporarily or they broke entirely. Imagine that such a storm would happen now. We would not be talking to each other. We would never get home because our cars and our bikes would never work anymore. So we're building a satellite which will allow science to predict and to better model the sun so that we know when these solar storms might happen and that we can at least have precaution activities on the Earth to protect electronics from this radiation.
Wow. I mean, this is just fascinating. We could never have imagined, this type of risks for I think it's not only kind of, everyday risk, but also like geopolitical and, everything will stop.
Yeah, there are a couple of, I think there are like 5 big threats which we have as humanity, we have no control over. There could be a massive asteroid. Okay, we'll also do a mission with that to divert an asteroid, but that's
we can go in depth
another podcast.
Yes.
We have a pandemic. We have the supervolcano stuff. We have other things, but in general, these are all things which we don't control. And one of those things is also big solar storms. We have no control over them. We cannot do anything. But maybe with Prova 3, we can start to predict them. And if we can predict them, we can start to see, okay, how could we actually prevent too much damage on the Earth when we know it's coming?
I mean, this is fascinating. And I think Belgium was the country that, I think 10 years ago, there were elections, and then one bit of that one bit in that electronic machine that was calculating the election results was affected by a photon or some radiation particle that flew inside that machine, and I think that
it flipped a bit.
Yes, it flipped a bit, so you can actually see like the extraterrestrial life, whatever you call that, affecting our everyday lives, and I think that's really an interesting problem. But maybe you could share one thing that you have found out during your journey as a space engineer that would surprise the everyday person. What could be the aspect that you didn't know, and when you worked as a space engineer, wow, just a wow emotion formed?
I think a wow is maybe a bit difficult, but I think there are 2 things which I realized when working in space. I mainly work with unmanned satellites, so meaning there's no person in that satellite. But I have a lot of colleagues which work with astronauts. There's actually an astronaut here. She flew 5 times the space shuttle. I talked with her over half an hour. Amazing.
We're interviewing her tomorrow.
Excellent. Say hi. What I realized quite quickly is that I had this aura around an astronaut. I had like this, these were like Uber people. They were like floating. I mean, they didn't have to go to the bathroom. They were like people which were not like every one of us. And I realized quite quickly that when you work in space, it's all about very practical things. Astronauts are people. They have to go to the toilet, they need to drink, they need to eat. And that's something they didn't make mistakes. We build sometimes things which go to the ISS. You think that an astronaut is the best person trained to run your experiment, and they do things wrong. It's just like, it's a realization that astronauts are not Übermensch, but it also means that everybody with the right mindset could actually be an astronaut. You don't have to be extremely skilled or extremely talented. A lot of people could actually do this very well. Another thing I found out was, but that's more as an engineer, I think it's called the law of big numbers. If you have a chance of once every millionth of time something will go wrong, because we're in space and because the satellites have to work for such a long time, you can be sure that it will happen. You cannot trust on the fact, it's only once every millionth of time. No, this will not happen for us. No, it will happen. Like the radiation you explained where a bit flips, it happens in space all the time. Memories, they flip, and you have to protect yourself for that. If you see an issue 3 days after launch on your satellite, this is not bad luck. This is the law of big numbers. It will happen again, and you have to protect from it. The worst thing which can happen to a space engineer is that you find a problem on ground, but before you can solve it, it disappears. And then you're like, okay, problem solved. You don't know how it disappeared, but it's not there anymore. You can be absolutely sure that once you launched, that problem will bite you and will possibly cost you a lot of time to recover from it. So nothing is shortened. There's a lot of uncertainty. The risks are there and the risks are real. That's how space works.
I think one of the most valuable things that we get from space exploration is the technology, is that the space is such an extreme environment that is often that from those extreme explorations, we get the technology that could actually benefit us here on the ground. And as you mentioned, maybe we could take that mentality of you have a problem. Yes, maybe it went away, but eventually it will come back. It's just the factor of time, that when it will come back. It's not a question if it will come back.
Indeed.
So I would ask you, why do you think space is so important for us as humanity?
I think space provides an unblurred, objective perspective on our vulnerable blue marble in space. Space technology has brought us a lot. Computers and foam mattresses and Velcro and all these a bit obvious examples. But I think what it really brought us is the value of taking distance. We're now here, we look at the harbor, and we're very focused on a local environment. Even leaders of a country, they are very focused on their very local little things, and they lose perspective of the entire Earth. A lot of astronauts tell when they come back from Earth that they have some kind of humble feeling that they need to take care of this beautiful planet, but only because they saw it from a distance. So I would say send all these presidents into a rocket. Some can come back, some others maybe not, but at least show them from a distance how from space there are no borders, there are no. From space everything seems very vulnerable and very beautiful. So let's take much better care of our planet. I think that's what satellites bring us every day. We have now an HD camera on the ISS. There's a YouTube web stream where you can look from the ISS down in 4K, I think even. So look at that and see like, my God, what kind of beautiful planet do we have?
Wow, I think that's a thought that really breaks the everyday hurdles and the everyday problems that we have now. And if you can actually see the as you mentioned, the beautiful blue marble, and compare it to all of the other planets that are really harsh, they're either hot, they're super cold.
You can't survive.
Yeah, you can't really survive. And here you have this beautiful 1 in a billion chance of developing.
Yeah, there's no planet B. People will say that, let's go to Mars and we'll start a new colony there. Humans are not built for Mars. We will never be able to survive there for long periods of time. We have to solve the problems on the Earth, and then you can explore Mars. It's fine, but it's not an alternative for the Earth. We will never get there in our lifetime. We have to take care of what we have here. And look, it's beautiful.
It's beautiful. We're sitting in this beautiful Antwerp, one of the most ancient ports in Europe,
Yes.
the second largest port in Europe now, and it's absolutely beautiful. The weather is beautiful, and I think, but this exploration, as you mentioned, could help us kind of bring that innovation and kind of zoom out on a more macro scale. And speaking of the technology, what technology you think in the next few years we could implement from the space exploration and implement it into the everyday lives of people?
It's a good question. I don't actually know that much of that specific topic. I think in the past you could see that in the times when the US and Russia were racing into space, the technology on Earth was driven by the technology from space, because there was so much money invested in building technology for space that it has always advantages for ground technology. I think now you see that space is becoming a lot more normal. There's a lot more money now going into defense and into pharmacy and those kind of things than into space. So space is not the driving factor for innovation anymore. I think you need to look for applications in space. What we do see is that the last couple of years, the prices of rockets has gone down a lot. So things which you could not do in the past, because the rocket was just the limiting factor because of the cost of a launch, are now actually becoming possible. You could actually start to think about business cases in space, which were never possible in the past because the launch was always the biggest cost which you could have. So what I think the next technology in space would be things which we thought about before. I mean, you could say the obvious, like internet from space. And then you go to the SpaceX, Starlink sites. But if you could build other constellations, making real-time video from the Earth to ground. There are satellites already making video, but there are only a couple. There are satellites which take pictures of the entire Earth every day. So if you could use that data to gather data, to feed that into an AI model, I don't know, and to learn something, I think that could be a new breakthrough, to acquire more data from orbit, which, again, it gives you an objective view. There is nobody, at least there shouldn't be nobody who messes with your data, who can say, I did not cut this part of the forest as I promised to do. You can see that from space, whether they did or did not do that. That's a very nice objective view.
Fantastic. I mean, this is just a fascinating conversation. And I would ask you about some of the problems that you had encountered across your journey as a space engineer. Could you identify maybe some of the problems that you encountered? And please walk me through the process of actually solving those problems, because I think that as you mentioned earlier, this is kind of the space is the extreme harsh environment that you need to do everything you can, and a lot of money is involved. So walk me through, what is the problem-solving process of a space engineer?
I'll take you back to May 2013. We are in Redwire, which is a small city in the south of Belgium. We're in the control station of ESA, the European Space Agency. And somewhere in Kourou, French Guiana, which is on the other side of the world, we have a satellite in a rocket. That rocket lifts off. I was there until a couple of days ago, making sure the satellite was fine. And I fly to Belgium, I fly to Redwire, and I am there as the primary operator. So I basically control the satellite. Everything seems nominal. The satellite appears, we can communicate with it, it looks perfectly normal. ESA is always conservative, no party yet, guys. We'll have to survive the first 24, 48 hours, and then we'll have a fancy dinner. Okay? 48 hours goes by, the satellite is just behaving perfectly. It's really doing exactly what it's supposed to do. We're going much faster than what we thought. We go for a fancy dinner, which is just 5 minutes walk. It's not a big city, so there's not a lot of restaurants, but we go there. And around 11 o'clock, we say, okay, well, we can go to the hotel, or there is another contact with the satellite. Typically, these contacts are like 10 minutes only. It's very short. In half an hour, shall we just celebrate and just go and see how well it's doing? So we walk back to the station. I sit in front of my computers, at my control station. The satellite appears, and we get memory errors. Satellite is not behaving normally and it's using too much current. The computer is warming up. Clearly, we had a radiation issue. We had radiation from the sun, which hit our memory and which created a short, an electric short. So we were using too much current. It was heating up. We had to do something. So first thing is isolate the problem. What do we have? We have one computer which has an overcurrent. It's using too much current. We need to make sure it's going off. Otherwise, we might actually burn something through. Luckily, in every satellite, we have two computers. So we do command from ground. We switch to the other computer. I've done a lot of satellites. We were never allowed to switch to the redundant computer because going to the other computer is actually leaving your satellite without control for a reasonable amount of time. Anyway, we switch and we see the redundant computer is fine. Okay, then you already know this is not chance. This is something which will happen again. So, okay, the next day we go back to the primary computer. The primary computer is fine. It is okay. It's working still. So the memory which latched is fine, but we just need to be aware. 2 days later, bam, again, it latches again. It is not by chance. It's a design issue. We have used a component which cannot stand the harsh environment of space. So again, we go to the computer, but each time when you switch computer, the satellite forgets everything. So it can't take pictures. It's really, it messes up our system a lot. We cannot do science then. So we thought about a system where we could say, okay, let's automatically switch to the other computer on board. But then the other computer would have to switch back immediately, because otherwise we lose our data, because the data is still on this primary computer. So we implemented a system which detects that there is a latch up. It then writes a small message into a shared memory which the both computers can access, and then we switch to the redundant computer. The redundant computer says, okay, I'm the redundant computer. I will read whether there is a message for me. It will read that message and say, there was a latch up on the primary computer.
Yeah.
I will just switch back. No problem. He switches back. On the primary computer, he also reads his own message, which he forgot because he completely power cycled. And he says, I had a latch up, but I was there and I was doing this, so I will immediately continue what I was doing. So we changed an issue, which potentially destroyed our mission, into every 48 hours, more or less, we have 3 minutes where we have no science data, but for all the rest, we still have perfect, good science data. It's really a very difficult technical solution for a very simple problem, which is radiation. But we pulled it off. And since then, the satellite is working.
Mm-hmm.
It was built for 2.5 years. It's now 12 years in space, and it's still doing its job every day.
So first, isolate the problem.
Yes.
Identify and kind of concentrate on, second, how you can solve it. And then you actually implemented some really creative way to do it. So it's not like, it's definitely not written in the manuals how to do it.
No, isolate the problem, test in steps how to solve the problem, automate. So that if it happens again, you automatically recover and you shorten the time.
Fantastic. I think this is really implementable not only in the space industry, but across all problems.
Yes.
In every business.
Yes.
And so it's really
learn from your mistakes. In the end, it's always the same. As an engineer, if you are as an engineer, you never encounter problems, you have the most boring job in the world.
Mm-hmm.
We are built as engineers to detect problems, to find problems, and to solve them. And then at some point we are done, and then we get bored.
Mm-hmm.
Now our satellite is in space, it's doing what it's supposed to do. I'm not interested anymore. I want to go for another project, which again has problems. That's what we do.
Fantastic. Yeah, that sounds totally reasonable. You just move on. And I think one of the projects as you got bored, and then you decided to write a book.
Yes.
You're not only a space engineer, but also an author. You wrote a children's book. So could you tell me a bit more about it? Why did you decide to do it? And maybe what's the key takeaway that you want the kids that read this book to take away?
I actually wrote 2 books. First book was called Journey to the Stars. Yeah, it was really about explaining space to kids in a very easy manner. It sold out. You can only find it in libraries, but it was translated into Chinese and South Korean. So there is somewhere in the world a Chinese child which gets inspired by my book.
Wow.
if that was the only thing I have achieved in my life, I would have been already very happy.
That's fantastic.
But then a couple of years later, there was Corona, and I have 5 kids, and I could see my kids their shoulders went down because they looked at the news and there was the pandemic. But on top of that, there was a climate crisis. There were wars. There's not enough food in the world. There's chemicals in our environment. These kids grow up with an extreme bias for bad news. They think the world sucks and the world is very bad. And then I read a book which is written by a Swedish professor, which is called Hans Rosling. I don't think he's alive yet still, but he wrote a book which is called Factfulness. And he goes through the UN, all the reports which the UN makes and all the reports which national governments make about statistics of countries. And if you look at what he reads, the world is becoming a better place every day. Much less people die from disasters and from environmental issues than years ago. If you get cancer now or you get cancer 40 years ago, you have a lot better chance of surviving. And especially kids, they do not realize it. Also, old people like myself, we always think the past was much better. Our parents, before social media, life was so much better. It is actually not true. If you look at the numbers, actually our world right now is much better than it was 40 years ago. And I thought, these kids feel part of the problem. They should be feeling part of the solution. So I wrote a book, which is called Will You Be the First Person on Mars? It's about space, of course, but it's also about medicine and about technology and about energy. And it lists the technologies which are currently emerging, which will make our life even better. I'm not saying in the book that there are no problems. There are a lot of problems in the world. And some problems are getting bigger and other problems are getting smaller. But I do feel and I do hope that technology will be able to solve a lot of those problems. So I want to invite the kids that read that book, be part of the solution. Don't be part of the problem.
To whoever is starting or just wants to start in the space industry, what is your advice to them? What are the first stepping stones to actually go into that fascinating field?
I think space is reachable for a lot of different people. You don't have to be brilliant and have an IQ of 130 and whatever. A lot of people can get into space. In ground systems, in space systems, in a lot of different things. I think the key is that you have to be optimistic. You have to believe that it's actually possible. I go to schools a lot, and these kids are usually fascinated by space, but they think that space is only something you can do in America or in Japan, some country very far away. I think the main thing is to be realistic, be optimistic, and know that in a lot of countries in this world, you can work in space. I have a perfect example. We hired a couple of years ago Benjamin, and Benjamin is a person from Ghana.
Wow.
He traveled with his dad to Italy, where his dad was working, and he said, I want to become a space engineer. And they didn't have a lot of money, so Benjamin's like, okay, where can I study space engineering? Where is the cheapest? Italy was definitely not the cheapest. He went to China. He learned Chinese as a Ghana person. He did his bachelor in space engineering in China. He came back to Italy, finished his master, did a lot of small little things, but could not get a job because he didn't have a European passport yet. I interviewed him for a job, and after half an hour, I didn't need to hear anything more. If you have the mindset of going to China, of traveling all across the world to just be able to learn something, he has the degree. He is smart enough. I don't need to test whether he's smart enough to become because he has the degree. I need to have the people with the right mindset. And Benjamin was a person with the right mindset. He's not working for us anymore. He went to the UK because his wife went to the UK. Okay. But we gave him a job. He did a perfect job. And now I heard, because we're still in contact, that he's actually starting a space company in Ghana to go back to his roots and lift that country up. Because also in Ghana, you can build maybe not satellites right now, maybe not rockets, but you can build ground stations, big antennas, which help the NASA and the ESA of this world to communicate with their satellites. So you do not have to be Einstein to work in space. Space is for a lot of people, and you just have to believe in it and be stubborn.
Mm-hmm.
Don't accept something outside space, because as soon as you're out, you're out.
That's really cool that this year's SuperNova theme is Shoot for the Moon. And our founder, Jürgen Ingres, is a huge fan of space.
We have Expo last year.
Yes, we have a few elements from the space stations at our venue. And maybe you could, you mentioned the technology that you achieved a few days ago, but what are your future plans? What do you want to achieve in the next X amount of years?
Well, maybe it's a bit disappointing, but I just want to keep doing what I'm doing. I work in a reasonably small company. I get a lot of respect from my colleagues. I think I have a lot of added value to the company. I can do all the amazing projects which we do. I'm too old or too. I don't want to go and work for NASA and land something on Mars. I mean, I do want to do something new. We have a Mars mission now, which we are starting to design. It's just paper, but I would like to be involved because it's something new. So I would like to keep doing new stuff, but I don't need to go somewhere else anymore. I'm very happy where I am. I think that's a big advantage in life, to be happy with what you have and not to always put the next dream there. I mean, I'm living my dream right now. I don't need to do anything else. I can just keep on doing this for another 20, 30 years, and then I'll retire and I will look happily back on what I achieved.
I think that's the thing that a lot of people want to achieve. Just continue doing what you're really good at and what you're really passionate about. But first, you need to find that.
Yes, of course.
Passion.
Yeah, you need to achieve it.
And maybe we could talk a bit about the private versus public sectors in space. As I understand, Redwire is a private company. So where do you see private companies being better than the public ones like ESA and NASA, and vice versa?
Yeah, I think in Europe there has always been a very good boundary of responsibility. ESA is not actually building something themselves. ESA is basically making sure that the money from the European taxpayer is spent well, provides technical expertise, is boosting industry capabilities, but they don't actually build things themselves. In the past, NASA did, together with partners, but in the past, NASA actually built something on their own. ESA always has taken the approach where they are the public side. They're making sure the money is there, that they select between the projects, that they trade off missions with scientists, that they take an objective view, and they empower the industry to do the work for them, to actually build the things. I think right now, commercial companies are still very much dependent on that governmental support from ESA, from NASA, because they get the projects, and it's important for developing new capabilities. But if you're talking about high resolution imaging from the Earth, from a satellite towards the Earth, this is capabilities which have been funded in the past. Now the commercial industry should be on their own to be able to turn it into a commercial business case. We should not get money anymore from the government to build another mission which does the same thing as before. We should be able to commercialize. And if it's not commercializable, then, okay, it's not a business case. Then we need to look for something else. Okay, there's also the defense part, where I think there's a lot of money now flowing into defense, which probably also will get a lot also into space. But I think there's now a lot of startups, a lot of space companies which are thinking about, okay, with a little bit of seed money, we can develop new capabilities in space, and then we're on our own. We can have a self-sustainable business case, and we don't have to be always receiving continuous government money, which in the end is not what ESA and NASA are for. They're not to continuously feed the industry with fresh money. They're there to feed it with money to build capabilities, which then can be used commercially.
Let's talk about the future for a bit. How do you expect the space industry to be in, I would say, 10 years? And maybe you could give a perspective of how would you expect the space industry to be in the 22nd century, so approximately 75 years from now. What is your ultimate dream of how the space tech should look like in 5 years and 75 years?
In 5 years. I think the key in 5 years will be standardization. Many people still build satellites like they built it 20 years ago. Also, we still do that. You have one specific goal of your satellite and you build your satellite around that. So each time you build a brand new satellite, just to be extremely optimum for that one thing which you want to do. I think what you see now is that since about 10, 15 years, people are building what they call CubeSats. 10 to 10 to 10 centimeters, standardized boxes. And you can put 3 boxes on top of each other. Then you have a 3U CubeSat, and it can do things. The CubeSats right now, they're evolving and they're becoming better, but they're not at the same level of quality, reliability, and then bigger satellites. But I think we should learn a lot of lessons from it because they do it at a very low cost with still a reasonable amount of quality, and they can scale very fast. I think where the let's say the normal space industry currently is still building it the old way, we should also learn from standardization and build standardized models on a computer, a battery, always in the same form factor, the same connectors, the same cables, to ensure that we can build something much faster, much cheaper. It might not be optimum in the sense that we could probably shave off a couple of kilograms, but because rockets get much more powerful and get much more cheaper, this couple of kilograms is not important anymore. You can actually make it a bit too heavy because the cost versus kilogram is shifting completely. So I think that's in 5 years what we need to do. We need to standardize much better to become cheaper and faster.
Mm-hmm.
In 75 years from now, my God, I have no idea. 75 years from now,
yes.
Where will we be?
Yes.
I mean, we always say that in 30 years we will be on Mars. According to Musk, we will be on Mars in 4 years. Well, I have my doubts, but okay. But I think in 75 years, we will indeed be traveling to places where we've never been before. Possibly also with people. There are moons around Jupiter which have liquid water. Let's go there. Let's see whether there's life on these moons. There are stars a couple of light years away. They have planets. Let's go there. It's going to take new technology because the current technology, we cannot get there, but we will find a way. It just will take time and taking a bit of risks and failing and trying again. And that's what humans do. We go and we explore and we move the boundary, we move the bar, and we continue.
I mean, that's just fascinating. I would ask you one off-the-record question, and if you don't like this question, we can cut it out. But do you think there are aliens?
Do I think there are aliens? I do think that there's extraterrestrial life somewhere. Yes, because I told it in my keynote. There are more stars in the universe, what we currently know, and we only see a part of the universe, than there are grains of sand on the Earth. I mean, if you're on a beach and you count the grains of sand, and you then think all the beaches, all the deserts, all the dunes. For every grain of sand, there is a star, and even much more than that. There's probably 8 or 10 stars. If we look at these stars, then we see planets around them. So the old vision about we are a very special planet around a very special sun, that's not the case anymore. We are not a very special planet around a very special sun. There are billions of suns like ours, and there are billions of planets like ours. And then I think it's just the law of big numbers. If in any warm planet where there is liquid water, if in a billion of those planets life evolves or life originates, then there will be other planets supporting that. I think the key will be to step away from looking for intelligent life. Because intelligent life, like we think we are intelligent, we don't know what we will think of ourselves in 75 years from now. We might think we were not intelligent at all. But finding intelligent life is probably difficult in the sense that intelligent life might not survive that long.
Mm-hmm.
if we look now at our planet and what we're doing with it, it might be that as soon as we think we become intelligent, and we're only going in space since 70 years, huh? Imagine that in 1,000 years, our Earth has been consumed. It's done. Humanity is over. We've messed up. It's gone. Maybe intelligent life messes up. They consume the resources of a planet and then they die. If you only have 1,000 years where you can find other intelligent planets or intelligent extraterrestrial life on other planets, you have to be extremely, extremely lucky to overlap with another one, which is then close enough to actually see it or sense it. So I think, yes, there will be, I think at some point we will find life somewhere. Will it be intelligent? I don't think so, but I don't know. But I'm quite sure that it's there.
I mean, this conversation is just the fascinating for my childhood dreams, you know. I always believe that there are some. And when a satellite engineer tells you that there are aliens out there, maybe not so intelligent, maybe they are intelligent, never know. It's just super fascinating. Stijn, thank you so much for this conversation. We would finish it off with 2 quick questions, maybe the most difficult ones,
yes,
but really important. First, since our podcast is called Superhero Conversations, we talk about superpowers of people. So what is your superpower as a space person?
I think it's difficult to say something. In Belgium, we are always very humble.
Yes.
And we don't like to brag about one another.
You need to be the Dutch.
I need to be the Dutch guy. I think I had the enormous fortune of always being surrounded by people which are smarter than myself. In my family, but also when I was studying at university, I could feel people were smarter than me. I work in a space company. I'm surrounded by space engineers. I mean, I can sense that some people are just outsmarting me by a lot. I think what I add is that I have, I think, very good communication skills, and I can be very impactful in meetings. I've been in this work for a long period of time. I've seen it all from when you're designing your satellite on paper to actually flying it. So when I say something in a meeting, I typically have a lot of impact. And that's, I think, where my superpower is. I can unblock a discussion which has been going on for months between our customer and our junior engineers by just stepping in that meeting and say, look, guys, but we've done this before. Look, this is how we did it on the previous satellite. Decision closed. We have to go for that way. And there is very little people which will say no to what I say. I don't know why, but I do have that kind of impact in meetings, and I like it a lot because I don't like to waste a lot of time. I'm very time efficient in my job and in my private life as well. And I like to be, okay, meeting of an hour, if we can finish it in 45 minutes, perfect. And I think I have that impact. I can bring confidence to the customer such that we can avoid endless discussions. And in space, believe me, there are endless discussions about stupid little details. I can end them quite fast because I have this knowledge, and I can also explain it in a way that I bring confidence to the other side of the table.
And the last question, what is your dream?
To keep doing what I'm doing right now.
Fantastic. That's just perfect answer. Stijn, thank you so much for this conversation, and have fun at SuperNova.
Thanks for having me. Have a nice day.